The journey of artificial intelligence has always been a tale of highs and lows, soaring optimism followed by harsh realities. For every breakthrough, there were roadblocks. For every visionary dream, there was a dose of sobering skepticism. And perhaps no period captures this dynamic better than the infamous AI winter. A time when progress in AI slowed, expectations were shattered, and funding dried up. To understand the AI winter, we need to revisit the optimism that came before it. In the 1950s and 60s, AI researchers were riding high. The logic theorist, general problem solver, and the pioneering work in symbolic reasoning had sparked a belief that machines were on the verge of becoming truly intelligent. Headlines proclaimed that human-level AI was just around the corner. Some researchers even predicted that machines would surpass human intelligence within a generation. But there was a problem. While these systems were remarkable for their time, they weren't nearly as capable as people hoped. Symbolic AI, for all its elegance, struggled with real-world complexity. Early programs could play games like chess or solve algebra problems, but they were brittle, easily thrown off by unfamiliar inputs or ambiguous scenarios. Let's start with the technical limitations. Symbolic AI relied heavily on predefined rules and knowledge bases, which had to be manually programmed. This approach worked well for narrow, structured tasks, but failed in domains where information was incomplete or constantly changing. In short, the real world was messy, and symbolic AI wasn't equipped to handle the mess. One of the most infamous failures came in the realm of machine translation. In the early 1960s, researchers at the Georgetown IBM experiment had demonstrated a system that could translate Russian sentences into English. It was a promising start, and the US government poured money into developing fully automated translation systems, believing they could decode Soviet communications during the Cold War. But progress was slow. By the mid-1960s, it became clear that machine translation systems couldn't handle the complexity of natural language. They struggled with idioms, context, and ambiguity, things humans navigate effortlessly. A Russian phrase that translated literally as, "the spirit is willing, but the flesh is weak," famously came back as, "the vodka is good, but the meat is rotten." The failure of these systems cast doubt on AI's broader potential. Funding agencies started to ask hard questions. If AI couldn't deliver on something as practical as language translation, what else was it failing at? The skepticism grew more pointed in 1973 when the Lighthill report was published in the UK. This government-commissioned report evaluated the state of AI research and concluded that progress was severely limited. The report criticized AI for focusing on narrow problems that lacked general applicability, effectively calling it a field chasing pipe dreams. The impact was immediate and devastating. Funding for AI research in the UK was slashed, and other countries soon followed suit. The US wasn't immune to the backlash either. DARPA, the Defense Advanced Research Projects Agency, had been a major funder of AI research throughout the 1960s and 70s. But as projects failed to meet expectations, DARPA shifted its priorities to areas with more tangible results. AI, once a darling of the tech world, became a field viewed with suspicion and doubt. But the challenges weren't just external. Within the AI community, there were growing divisions over how to approach the problem of intelligence. Symbolic AI, the dominant paradigm, was increasingly seen as inadequate. Critics argued that intelligence wasn't just about manipulating symbols. It was also about learning from experience, adapting to new environments, and processing vast amounts of data. This division led to the rise of alternative approaches, like connectionism, which focused on neural networks, models inspired by the structure of the human brain. But in the 1970s and 80s, neural networks were still in their infancy. Computing power was limited, and algorithms for training these networks were poorly understood. As a result, connectionist approaches struggled to gain traction, leaving the field of AI at a crossroads. By the early 1980s, the AI winter was in full swing. Universities scaled back their AI programs, companies abandoned research projects, and the field's brightest minds began to drift into other areas like computer science and robotics. AI, once a symbol of technological progress, became a cautionary tale about overpromising and under-delivering. But here's the thing about winters. They're not permanent. Beneath the surface, AI research continued, even if it was underfunded and underappreciated. Researchers in symbolic AI, neural networks, and robotics quietly laid the groundwork for future breakthroughs. For example, in 1986, a paper titled Learning Representations by Back-Propagating Errors was published by Geoffrey Hinton, David Rumelhart, and Ronald Williams. This paper introduced a method for training neural networks that would later revolutionize the field. At the time, it was a small, overlooked spark, but it planted the seeds for the machine learning revolution that would come decades later. Meanwhile, expert systems, the domain-specific AI tools developed in the 70s, continued to find practical applications in industries like medicine, engineering, and finance. These systems weren't flashy, but they demonstrated that AI could provide real value, even if it wasn't living up to its loftiest promises. The AI winter also forced the field to mature. Researchers became more cautious in their claims, more rigorous in their methodologies, and more focused on solving practical problems. In a way, the winter was a humbling experience, a reminder that intelligence, whether human or artificial, is an incredibly complex phenomenon that can't be rushed or oversimplified. By the late 1990s, the ice began to thaw. Advances in computing power, data storage, and algorithms breathed new life into AI. Neural networks, once dismissed as impractical, began to show promise in fields like image recognition and natural language processing. The rise of the internet created a flood of data, providing the raw material that modern AI systems depend on. Looking back, the AI winter wasn't just a period of stagnation. It was a crucible. It tested the field's resilience, forced researchers to confront their assumptions, and paved the way for the breakthroughs that followed. The lessons of the AI winter are still relevant today. They remind us to be cautious in our optimism, to temper our expectations with realism, and to approach AI with a sense of humility. At the same time, they highlight the importance of persistence. Even in the face of setbacks, the pursuit of intelligence, whether artificial or human, is a journey worth taking.